Here we are, everybody. This is 6.3, an introduction to linear equalities. We're going to start with some notes, and I actually just I like the notes from this version right here. So what I'm going to get you to write in the notes section, even though I've printed the other version, is this part right here. So you can just kind of ignore, this part for now, ignore this parts for now, or maybe I'll read that, but this is what I would like you folks to write down. So an inequality is a statement that one quantity is greater than or less than, or greater than or equal to another quantity. So please write that down in your note section. And I would also like you to write down these symbols, that this is greater than, this is less than. With the line underneath, it's greater than or equal to. And with this line underneath, it's less than or equal to. So I'll give you folks, a couple minutes to get that down. If you could probably pause it here. If you could write down this part in your notes section, that'd be great. So give that a little pause. And I will read this part. I like this description, actually. Some notes so sometimes a variable can be more than just one value. Okay, so often we have something like, a plus 3 equals 7. This can only be one thing, okay? This can only be 4, okay? Because it's only true. This is the only thing that makes that true. So A can only be 4. But in inequalities, it can be a range of things. So in cases such as this, we use inequalities to describe them. So for example, a highway speed limit is 80 kilometers per hour. So vehicles driving on this highway should be less than or equal to 80 kilometers per hour. So as an inequality, we would write this car speed as less than or equal to 80 kilometers per hour. So you don't just need to be exactly 80 kilometers. You can be less than that as well. So I'll go back to our notes. So you should have written those notes right here that I just showed you. And I will do now the rest of the notes with you. So state 3 values of the variable that satisfy each inequality. And satisfy just kind of means like makes it true. That's what I think is a good description of what it means by satisfy. So we're looking for something. C needs to be less than 7. So C could be 6. It could be 3. It could be 1. There you go. Those are 3 numbers that are less than 7. And I always think about this. I mean, I learned this when I was very young, and I still think about it now, even as an adult. I think about this. So we have C less than 7. I think about it having little teeth, and it always wants to eat the bigger one. Okay, so I still think about that, even though maybe it's a bit juvenile, but it helps. Here we go. We're looking for A needs to be greater than, or this little line, remember, means equal to -3. So 3 numbers that would satisfy this, we could do -3 because it can be equal. And now it needs to be greater than this. So also, 2 is greater than this and 10 are greater than that. Here we have n is greater than 5. It doesn't say equal to, so it needs to be greater than that. Can't be 5, but it could be 6, could be 7, could be 8, could be, 243, whatever you want. And finally, we have another kind of less than, or this little line, remember, is equal to. So we're saying that y is less than or equal to -1. So we could have it as -1. Let's do that. But also -2, -7, -23. Okay. So to satisfy means to make this true. So it's true that -1 is less than or equal to -1. In fact, is equal to. It's true that -2 is less than -1. It's true that -7 is less than -1. And it's true that -23 is less than -1. Okay, let's do a few more. We're going to be looking at some number lines and writing the inequalities that they would represent. So one thing that's really important to remember, and you can maybe write this here, that a filled in dot is going to equal to, and a not filled in dot like not equal to. So this would kind of be like our greater than or equal to or less than or equal to, and this would be our greater than or less than symbols. So this means it includes that number, and this means it does not, does not include and does include. Okay. So let's look at this one. It's a filled in dot, and if you can't see it, this line is going this way. So it's saying that our x is going to be greater than or equal to -6. And it's going up. So this would be like our 0. This would be our positive numbers. So it's going to occupy all of these numbers over here. So it's going to be greater than or equal to that -6. Here we have a not filled in dot, and our line appears to be going this way. So now our x's are going to be, looks like less than 4. It's not going to be equal to, the dot is not filled in, so it does not include 4, but it's all of these numbers that are less than that. Okay, let's do the next one. We have a not filled in dot again, so it's not going to include this, which appears to be 7.5, so halfway between 7 and 8, and our line is going this way. So it looks like our x is going to be greater than 7.5. So it's going, towards the positives. So it's, that's a negative. So it's increasing. Our x's are going to be more than 7.5, but not including 7.5 because the dot is not filled in. Here we do have a filled in dot. Our line is going this way. So our x is going to be less than or equal to -12. So it's going to be all of these numbers here, which are less than -12, and it's going to include -12 because we have the filled in dot. Okay. Let me do a few more on the next page. We need to write an inequality to describe each situation, then graph it. Okay, so you have a gas tank and a car contains no more than 55 liters of gas. So it could include 55 liters of gas. It could get up to 55 liters of gas. Can't go above that. So X needs to be less than or equal to 55 liters. So now we can, make this, if we want, 55. And maybe let's do increments of 5. So this could be, 50. This could be 45, 40, 35, 30, 25, etc. So our line is going to go that way. It can only go to, that would be 20, 15, 10, 5, 0. It can only go to 0. I mean, you can't have less than 0 of a gas tank, but it also can't go above that. So I guess we could probably, it hasn't asked us to do this, but it needs to be, greater than or equal to 0 and less than or equal to 55. But it hasn't asked us for this, so I would say this is the answer that we're after right here. And let me just complete this line then. So go to 0. And now the minimum age you must be to watch the movie is 13. So you need to be greater than or equal to 13. Okay, so you need to be 13 as possible, or you need to be above that. So we can start, say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's do that as 13. It's including 13. So I'm going to use a solid dot to show that. And then our age is going to move this way. So that would be 13. That's 0. We can label as 14, 12, 11, 10. You get the idea. So it's going to include all of those ages above 13, but also including 13. So thank you so much. I will let you know which questions I'd like you to do.